Okay, so let's start for the today's session. So today we'll just go through the from week 1 to 6 and whatever like important topics are there, we'll be discussing only those. Okay, so I'll just go through.
Sir, your voice is bit.
Okay, you're not able to hear me. Is it fine now?
Sir, it is fine.
Yeah. Okay.
So can you first revise week 5 to 8, sir, like the important points?
7, 8, 9, 10, 11, and 12. And for each of these values, I identify what is
Please, can you please mute me? Mute yourself. So whoever was saying, can you please? Okay, so everybody should mute yourself. So I was saying, I'll be discussing today. We have a session where we'll be discussing 1 to 6, and then we have 2 more sessions. Okay, there we'll be discussing. We like basically today we are just discussing the starting question, and then we'll be having 1 more session where we'll discuss calculus and then the graph theory. Okay, so 2 more sessions is been scheduled, so don't worry about that.
So can you just say what will you be discussing each time?
So
So can
tomorrow,
you just say what will you be discussing each day, sir, so that we can prepare?
yeah. So today I'll be discussing the basic stuff like the graph, not the graph. So the quadratic equation, the straight line, the starting portion, week 1 to 6, that for different types of function, and then the logarithm function, the relation function. So all those things we'll be discussing today. And then the next session we'll be discussing the calculus part, the continuity, differentiability of different functions and all. And then in the last revision session, we'll be discussing the graph theory. Okay. And today, whatever I'm discussing, all those points are important. If somebody hasn't went through, like if you don't have much time to go through the each and every video, you can just rely on whatever we are discussing today, and whatever the concept I'll be discussing, just practice some questions from those questions. I think so you'll be able to solve most of the problem in the exam. Okay. Is it fine?
This revision session will be taken by you only.
The other revision session, I'm not sure who will be taking that, but yeah, so that I'm not sure who will be taking.
Excuse me, sir.
Yeah.
So when I was doing, I think that the practice assignments or I think that PYQs, I found there were partial equation, partial or differential equations. Is it in the syllabus of the
Differential
first year?
equation, I don't think so. They'll be asking differential equation.
I think it was partial fractions. I think it was partial fractions integration, I guess.
Partial
Is it there in the syllabus?
Partial derivative also, I don't think so. They'll ask me. Where did you find
Sir,
that?
only professor just discussed about it in very brief. It wasn't even in the practice assignment either. So that was just to clarify that there exists some properties about integrals of definite integrals, which include some properties of King's property as such. But no such questions are there in any activity or graded assignments.
Okay, so questions I am not aware of, like whether, but okay, I have to confirm that once whether they have asked any questions from those topics, but most probably there won't be, because not been touched nicely, like just the brief they have given, but I don't think so. But I need to confirm that. Maybe in the next session I'll be in the good position to confirm you. You can ask me anything from whatever I am taking today. Okay. So
All right,
on the
sir.
basis of whatever the paper has been made, I just went through the paper. I have no happened. I just seen the content, whatever has been asked from week 1 to 6. Okay. So those questions, those are very important. Those questions I'll be discussing today. But for partial derivative, I am pretty like I'll be in the better position to confirm that in the next session. Okay. Or maybe whoever will take the session, I'll ask them to confirm. Okay, because those topics is not been like it's been touched, but it's not been discussed in the great detail. Okay.
All right, sir. Thanks, sir.
Yeah.
Yes, sir,
So next session, yeah, and you can go through the this thing I'm telling you for continuously, like last 2-3 session, whatever I have taken. to go through and solve the previous term paper from wherever you are getting. Maybe I've told the team to upload that. I guess they have uploaded the previous term papers. Go through that in the supplementary content. I guess it's there. Solve that paper. If you are able to solve that last 2-3 terms of paper, like the in-term paper, I'm pretty sure you're in a good position to solve at least 50 to 60% of the problem. Okay. I don't think, and then if you're solving previous term paper, you'll not get a shocker, like you'll not get shocked after seeing the paper, final paper. Okay. So
Actually, it's not been uploaded, but yesterday Ganesh sir took the one PYQ discussion of 21 question. It
so
was a
he'll be
PYQ
discussing.
only.
Correct. Yeah. So he will be discussing. So you can attend those session also. He'll be discussing the previous term ka papers one from, I guess, in the next lecture also, whenever he'll take the Ganesh, he'll be discussing the previous term papers one. Okay. So we have told them, excuse me. So we have told them to discuss the previous term papers only, because that will help you. And try to solve from your side also. Okay. It's not the time to go through the lectures again. If you have made some notes, that is well and good. Go through that. If you haven't, so whatever the slides that I'll be discussing today, you can go through that slide. Okay. And some questions I'll be discussing, maybe 3-4. Those are like most important. You should be practicing. At least you should be knowing how to solve those type of questions. Okay. And the weightage is good for the like some in papers, like weightage for week from 1 to 6 is not that much, but you are getting some problem, 20 to 25% to 30% of the problem you are getting from starting weeks also. Okay.
Excuse me, sir.
Yeah.
What will be the percentage of week 1 to 4, and 5 to 8, 9 to 12
I
in
told
this
you,
end term?
we'll be having from starting 1 to 6, we'll be having some 30 to 35% of the marks. Okay. If the question paper is of some 50 marks, we'll be having some, you can calculate the 50 marks or 18 marks from the starting 1 to 8 weeks, 1 to 6 week. Okay. Graph
Okay,
theory will
and
be having a good weightage. Graph theory will consist of some 30%. Only the graph theory, like the last 3 weeks of content. Okay. So you should be practicing graph theory. Like some simple concepts only, not that difficult. Some spanning tree, how do you calculate the spanning tree? Or some basic like minimum cost in the spanning tree itself. Like you have 1-2 algorithm. Even you know now one algorithm will be able to solve. Will not be specifically ask you, okay, solve with this method and all. So if you are being asked to just minimize the cost, you can just use any of the algorithm to solve those problems. And some basic problem from adjacency matrix. So it's not, I don't think so. You'll be having struggle in from the graph theory. Those papers are pretty simple. Yeah, from the starting weeks, you can get some questions from relation function. Those can be difficult, but yeah, if you are aware of the concept, I guess you'll be able to solve. Okay.
Sure.
Yeah, so I'll start the session. I'll ask you some problem also, don't worry. Just go through the session itself and you'll be in the good position to solve each and every problem.
yes, sir.
Yeah.
Sir, if possible, could you please like increase the volumes because it is very low. I don't know whether it's for everyone or just for me.
It
It's just for you, Danya.
clearly.
No, I think it will help if it's a bit increased.
Okay, but I have I need to then close my doors and all because my 100%. Okay, let me try without this headphone. Is it fine now?
Sir, this is okay, but earlier was good, sir.
Yeah, sir. Earlier was better actually.
This is better, right?
Yes, sir.
Yes.
Yes.
Yes, sir.
So can you see the screen? Is it visible to everyone?
Sir.
Yes, sir, it's visible.
So from the first week, so this all concept is pretty simple. I am not going to discuss this. I don't think so. You need that also, set and the basic concept that you are already aware of. What is set, the type of set, and only one thing I should be saying that if you have a set, so the element, the items that you have generally is called as element, and the one of the best properties of set is that the order doesn't matter in set. Okay. Duplicate also doesn't matter in a set. If you have like 1, 2, 2, that means you have just 1, 2. Okay. And cardinality, you are already aware of the number of elements that are there in the sets. Okay. It's not that important. Yeah. So whatever is important, I'll tell you. So you can just start from the relation. Okay. This is the most important concepts from your week. Okay. This week, this is the most important concept that you should be knowing. All the 3 types of relation you should be knowing. You can be asked anytime about different relation is been given, and then can be asked which of the following is the correct. It can be in the form of MSQ. Yeah, and one more thing, from set you can be asked some simple questions like that you solve using the Venn diagram. Okay, I don't think so that is needed to discuss there. Venn diagram, you are already aware of that, right?
Yes, sir.
Yeah. So if you have some question from the Venn diagram, just try to solve that simple problem, not much complicated, just with some 2 variables, A and B, and then A and B is given, then you need to ask A intersection B. That's such simple questions. If you are if you are able to solve that, it's well and good from the set. Okay, not much is important, like from this exam point of view, finally. The things that you should be aware of, the relation, the 3 types of relation, the 3 types of relation and the function and the different type of function. Okay, so I'll start from the relation. Okay, somebody was saying something. Yeah, Vivek, you asked something. Anybody has any question? No, right? Okay, let's start this relation. So Cartesian product, you are already aware of that. Like if you have some 2 sets A and B, and both the sets are some non-empty set, so the Cartesian product will be what? Will be having a pair of words from one from A and one from B. And your relation, basically A from B will be the subset of whatever the Cartesian product that you have from A and B. Okay. Here, only one important thing is in the relation, the order is important, because if you have some relation A to A is related to B. Okay. Okay. Let's, for example, you have some relation A is related to B. And then, okay, give me one where let's, for example, we have some set 1, 2, 3, and 1 is somehow related with some relation R to A. Okay, so that doesn't mean that A is directly, like in the similar way A is related to 1. Okay, if you have some function, it's just for the example, I'm just saying you why order is important here. If you have some x square function, okay, if you are putting some values here for f1, you are getting, okay, for 1 1 it is fine. For if you are putting 2, you are getting 4, but if you will put 4, you are not getting 2, right? So here the order is important in a relation. Okay, that is why in the set it was not important, but in a relation the order matters. Okay, that's the one important thing here. So that's why, so in the slides, I have written all the things. You can just go through the slides. Don't have much time to go through each and every video. So this is an important concept. So you can be asked in the MSQ, like which of the following statements are correct. For the set, is order is important, order is not important. For the relation, let's, for example, I'm giving MSQ, which of the following can be correct. The first statement is for a set, order is important. For set, duplicate, you generally count the duplicate also. So the duplicate matters. And the third statement is for a relation, order doesn't matter. So how many of the statements are correct?
That order is more important.
I think no one.
Yeah, so none of the statements are correct. So you can be, any questions can be framed like this. Okay, that's why I've written all the important concepts here. Okay, none of the statements are correct because for a set, order is not important. For a set, duplicate also doesn't matter, and for a relation, order matters. Okay, so that's the reason I told you order. Yeah, let's come to the three important properties of a relation. A relation can be most of like the relation. The first important properties is the reflexive property, reflexive relation. Okay, and how do you define that? Let R be a relation on some set S. So S has been given, and then relation R has been given, and R is a relation on a set, some set S. Okay, that is some non-empty set S. R is reflexive relation if and only if for all X. So this word should be always remembering this all. Okay, it's not for some cases, it's for all the X that belongs to S. You should be having XX. Okay, if you have, let's for example, in set S, you have 5 elements. Okay, then what can be the minimum number of elements that should be present in a reflexive relation? Can somebody tell me if you have a 5? 5, right? And all.
Sir, just one out in case of a set, does duplicate element matter?
In a set, duplicate doesn't matter. Okay, yeah.
But
So,
order does not matter.
no, both doesn't matter. Duplicate also, order doesn't matter in a set.
So, for example, we can have in a set the 2 times, for example, set of numbers, we can have 1, 2, 2.
That means you have just 1 and 2.
Okay, so duplicate does not matter.
Yeah, duplicate doesn't matter for a set. Okay, so that for a reflexive relation, the one and most important word here is all. For all the X that is there present in the S set, some set has been given, some set S that is non-empty set, and you have to find out some relation has been given from that set itself. So R will only be a reflexive relation if and only if all X that is belongs to S, that is belongs to S, you have XX is there present in the R relation. Okay, then one you can say that R is a reflexive. Let's for example, you have S equals to ABCD. Okay, and then R1 is AABBCC. Is this a reflexive relation? Can somebody tell me, is this a
Sir,
R1?
no, sir.
No, sir.
No.
Any confusion anybody is having, please ask me. Like, this is the most important concept that we are discussing from week 1. If you are able to know these 3-4 things, I guess you'll be able to solve problems from this.
So what is identity relation?
Okay, I'll discuss that, but first discuss this. Okay, reflex. I'll go through the each and everything. Okay.
Could you please one more time explain?
Yeah. See, for a reflexive relation, that is a relation has been given. Okay, and then that is a reflexive relation only if for all the X. Let's for example, you have S. You were having ABCD as some set, as non-empty set, and then R is a relation being given on S. Okay, then R can be a reflexive relation. One and if and only if for all X that is belongs to X is what? Can if I'm asking X1, what is X1? The first element of S is what?
A.
Right. What is the other element?
B.
The third one is C and D.
C.
So for all X means what? We should be having AA, BB, CC, DD. Correct?
Okay.
Is this clear to everyone?
Yes, sir.
So,
Okay,
For
so
all
tell me, I'm just giving you 3 examples. How many of them are reflexive relations? Just tell me, take your time, maybe 10 seconds, 20 seconds, and then tell me.
2, R2 and R3.
R2 and R3.
R2 and R3 are reflexive.
Anybody is having any doubt on this?
R2 plus AB is reflexive.
R2 is reflexive, sir.
R2
and
is
R3.
reflexive. Is R3 reflexive?
Yes, sir.
Yes, sir.
Yes,
sir.
sir.
Okay, yeah, correct. R3, anybody is having any problem in R3? Why R3 is a reflexive? Because I only, so see, the condition here is only on X. It's not on R. Okay, it's what is there? All, for all X that is present in the set S, XX should be present. It doesn't told you whether XY or ZX or anything else is present. If all these four are present, okay, for all the X, if this is present, then you can directly say it's a reflexive. Other than that, anything else can be present also. Okay, we should not be worrying about that. Is this clear to everyone?
Sir, it means if I have taken AB and BC as BC and CD, then that is the reflexive.
What can you repeat that?
AB, BC, and CD.
How is that reflexive function?
Both the elements should be same.
Okay, you gave an example. Let's, for example, this is R2. What did you say?
AB,
Okay, AB,
BC,
BC,
and CD.
CD. Okay. How? Okay, for reflexive function, what should be the condition?
XX. Okay.
XX. That means AA, EB, CC, DD. If these four are present, and apart from these four, if AB, BC, CD is present, then also it's a reflexive. But this should be must.
Okay. That is the priority. First priority. Okay,
Correct?
priority. Yeah.
Okay.
right.
So, okay. And for the identity matrix, only this should be present. So if R2 is R2 identity matrix,
Yes, sir.
Yes, sir.
Yes, sir.
is R3 identity matrix?
No,
No.
sir.
No. So that's the difference between reflexive and identity. So whoever was asking, is this clear to you?
Yes, sir.
Yeah. So, okay, I'm asking one statement.
No, why is R3 reflexive? I did not understand why R3 is reflexive.
Okay, R3, okay, so R3 is what? R3 is this R2 plus AB. So R3 is basically AA, BB, CC, DD, and AB. Okay, what did I told you? What's the statement? For all X belongs to set S, XX should be present. So what are the all X, A, B, C, D? If you have for all X belongs to S, so that means all X are what? A, B, B, C, C, D, D. Apart from that, anything else is present. I'm not like worrying about that. Only I need to worry about that this four things should be there. A, B, B, C, C, D. Okay, if there was E also, let's for example, if you have A, B, and C only, that means what? For A, B, C, if you have set S as A, B, C, which of the following are, how many of them are reflexive now? If you have only set S, A, B,
Only
C,
R1.
R1
Only
is
R1
also,
would be.
no, R2 is also there, right? So, okay, let's for example, okay, so R2 it can't be because of the DD and D is not present.
Yes, sir.
Sir,
Yeah,
R1 to
because
R,
of that reason, not because any extra points are there. If you have, let's for example, the DD is not there, the AB and BC is there. Okay, and DD is not there. This is not there. For set S equals to A, B, C, now can you tell me R2 is reflexive or not? This three
No,
and
sir,
this,
it's not reflexive.
it's reflexive because you have.
Oh, yeah, after you cancel DDs.
Yeah. Now it's because A, B, B, C, even though anything else is present, we are just worrying about this thing, this word. For all X, XX should be present. That's it. If this is present,
Oh, all right,
it's a
sir.
reflexive.
Understood, sir.
Got it?
Understood, sir. Thank you.
Yeah.
Yes.
And for the, so whatever you were saying, that is identity matrix. That means only this should be present. XX for all the X. Other than that, if anything else is present, that is not identity matrix. Sorry, identity relation. Is this difference clear to everyone? Yeah, go ahead.
Sir, for identity matrix, there should be all elements x comma x, but there shouldn't be any.
Only those elements. Yeah, only those elements. But here, not only those elements. Apart from this also, but this should be must. Apart from this, if anything else is there, well and good. But that is reflexive. Okay,
got
is this clear to everyone? If you are
Yes,
getting
sir.
any problem in the exam, you will not be doing mistakes, right? Okay. Now come for the symmetric relation. What is symmetric relation? Can somebody define, or should I define? I just wrote it here. R is a symmetric relation if and only if. So here also, for every xy belongs to R, it's not, there is no condition on S. Just the condition, whatever you are saying. Let's, for example, you have some relation R, and then you have to say whether it's a symmetric or not. Then for all xy, yx should be present in that x. It's not that if you have A, let's, for example, 1, 2, 3 is there, and you have R1, 1, 2, and 2, 1. Is this a symmetric relation or not?
Yes, sir.
Yes,
So-
sir.
It is.
It is a symmetric relation. Okay.
Yes.
Because for every xy belongs to R, it's not anything, it's not saying anything about S. Okay. For any xy, yx should be present. This is what the condition it's asked for. Okay. Is this clear to everyone?
So,
Yeah.
so one thing is that earlier one symmetric was reflexive was dependent on the set that we are using, and symmetric
Reflexive
is-
are dependent on set, because
And-
all the elements should be there, but here it's not dependent on set.
it dependent on relation.
But if you are getting anything apart from that set, that is not like, it's not, this relation is not like, if let's, for example, you have 3, 4, that means what, 3, 4 is not present itself inside. So it can't be. How can you build a relation? Because this relation has came from the Cartesian product of S, right? Correct? 3, 4 can't be there because 4 itself is not present in the set S. So 4 can't be there.
Sir, 2 is symmetric as well, no, sir?
Anything else you can give 2, 2. If you are giving 2, 2, if you are giving 2, 2, that is this symmetric? 1,
Sir.
2, 2, 1, 2, 2. Yeah, go
Sir.
ahead.
Yes, sir.
Yes,
Okay.
yes.
If I'm asking 2, 3, is this symmetric now?
No, sir.
So,
No.
No.
Not symmetric, because it should be, what did I say? For every xy means this is done, 1, 2, 2, 1 is present. 2, 1, 1, 2 is present. For 2, 2, 2, 2 is present. For 2, 3, where is the 3, 2? 3, 2 should be there. Then only it can be symmetric. If not there, it's not symmetric. Okay?
Yes.
Sir,
Got
Yeah.
it, sir.
if this relation contains only one as a
Okay.
Yeah.
Okay, this is 1, 1. Yeah,
Yeah.
this is symmetric, right? Because for every xy means I have only one element in this relation, 1, 1. So for this, for me, x equals to 1, y equals to 1. Right? Is yx present? Yeah, 1, 1 is present, right? 1, 1 is the yx. If this is present, this is a symmetric. Correct?
Okay, because both pair are same, so we only write one.
Correct. Got it? Any confusion in this?
sir, after adding 2, 3, this becomes asymmetric relation.
Did I talk about asymmetric? Okay, asymmetric, I'll discuss it in the end, but like, if you want to, I can discuss it, but don't get confused with asymmetric. Okay. First, I'll discuss these 3 and then I'll discuss asymmetric. If you want to, I can discuss. Asymmetric is basically, so there is a difference between asymmetric and antisymmetric also.
Sir, yes, sir.
Correct?
Excuse me, sir.
Yeah.
Sir, before you proceed any further, can you share this like PDF in the chat, sir?
This PDF, huh?
Yes, sir. I don't know. We can copy the notes like while you're teaching us your notes.
Okay, so how will we share this? Can we share in the chat box? Can we add in?
Yeah,
Oh.
I think so, sir.
Okay.
It will be available in the portal, no, sir.
This slide, I'll have to ask them to upload, but I guess this should be the file, but I'm not sure whether this is. Okay, let me check it. Just check it whether this is the same file. I guess this should be the same file.
Sir, can we quickly discuss the anti-symmetric and asymmetric? Because after this it will be confusing. If we discuss it along with symmetric relation, it will be clear. Just quickly, you can go through that.
Yeah. So did you get the file first of all?
So it's downloading. So I'll let you know if I can download.
Yes, sir. We got it, sir.
Got it right. Let's one second. 1 second. I'm just stopping.
It's the same document, sir.
Chennai, everybody. Not working.
Discussing about the symmetric matrix. Symmetric, is it clear to everyone? Symmetric?
Yes, sir.
Yes, sir.
Okay, so please mute yourself like bullets. Please, everyone. So now, anti-symmetric or asymmetric, if you want to build it. So anti-symmetric is what I didn't wrote it, but okay, I'll write it here. But I don't think somebody is going to ask you. What is anti-symmetric? Can somebody explain? A relation R is said to be anti-symmetric for which condition? On set S, we are having R is anti-symmetric on.
If
A comma B belongs to R and
who is?
can I, sir?
Yeah. Go ahead.
Yes, sir. If A comma B belongs to R and if B comma A is also in R, then A must be equals to R. And if A comma B belongs to R and B comma A does not belongs to R, then A must not be equals to R. I mean, A must not be equals to B.
Yeah, correct. So if we have R is an anti-symmetric on set S, if we have some relation, like let's for example some xy and yx, both are present, that means there can be only one condition. X should be equals to y.
അയച്ചു വിടറി നമുക്ക് നട്ടമുള്ള കാര്യമൊന്നും അല്ലല്ലോ. പിച്ചല് അപ്പ പിച്ചല്.
So you have to mute all.
ഞാനും പിച്ചു. അപ്പം പിച്ചട്ടെ. അതന്നെ. പിച്ചൽ. അമ്മ ബേബിക്ക് ഷാർക്ക് വെച്ച് കൊടുത്തേ അമ്മ. ബേബി ഷാർക്ക്.
Sir, can you mute everyone?
Yeah,
So sir, identity relation will not be anti-symmetric.
Identity matrix.
Identity relation, sir.
Okay, identity relation. If you have something 1, 1 or 2, 2 or 3, 3 on some relation S. Is this satisfying this condition?
Yes, sir.
Okay, so is this anti-symmetric or not?
So, sir,
What did I say you? Anti-symmetric doesn't mean that it is like all the relation which are not symmetric is anti-symmetric. That doesn't hold. And this is the example, best example. If you have 1, 1, 2, 2, 3, 3, then sir, if you have some set where only 1, 2, 3 is present, is this a symmetry?
Yes, sir, it's symmetric.
Yes.
yes, sir.
Is this
Symmetric.
anti-symmetric?
By definition,
Yes. No, sir.
Yeah. Why no?
But sir, by
So
definition,
1 is not equal to 2, no? Here. So how it's anti-symmetric?
1 is not equal to 2. If you have 1, 1, 2, 2, 3, 3, I told you what if x, y, y, x is present, and that can only be one condition. X should be equal to y. So here x, y is this one. This is x, y. This is x, y. For
So
all these elements, is x, y both are same,
X are same,
Yes.
sir.
right? So this is anti-symmetric.
yes.
Sir, is this mean that every reflexive relation is antisymmetric or only identity relationship is antisymmetric?
No, all the reflexive won't be because
relation.
for any reflexive relation, you can have all this. Apart from that, also you can have some 2, 3 and 3, 2. Correct?
Okay.
But those are not same, right?
And it means if we have identity relationship, then it is antisymmetric also.
Correct.
Along
you
with
can say that.
symmetric.
Yeah.
Anti-symmetric relation is a subset of reflexive relation, isn't it, sir?
Yeah. Correct. That is also correct.
So,
So identity
so with
is a
2,
subset.
so with 2, 3 and 3, 2, this becomes only a symmetric relation, right?
Yeah, that is only a symmetric relation. That is not a anti-symmetric.
Okay.
Okay, for anti-symmetric, just have to see if x, y, y, x is present, then x should be equal to y. If that is not happening, it's not anti-symmetric. Okay, nothing else you have to check.
So, but in previous set we wrote 2, 2 and that was symmetric.
Yes,
So
sir. Exactly.
What?
in the previous example, when we were doing the symmetric, right? We
Yeah.
actually wrote 2, 3, 3, 2, 2, 2. In the you gave
This
the
example.
example.
Yeah.
Yeah. So here, if we write 2, 2.
Okay.
So
Yeah, this is symmetric, no?
yeah. So, but x is equals to y here, right?
For all the cases, not for only one case. Anti-symmetric
Okay, so for
is
all
for
the-
all the cases. And
Okay,
anti-symmetric. Okay. If you have just 2, 2, then it is anti-symmetric and symmetric.
Okay.
Okay.
Okay, sir.
Is this clear to everyone?
No, then by this way we can even say that antisymmetric relation is a subset of the symmetric relation.
Anti-symmetric is a subset of symmetric.
Yeah, by what we just did.
No. How is this possible? If you have this example you saw, right? 1, 1, 2, 3, and 3, 3. This is what? This is symmetric. But this is not anti-symmetric, correct?
So it can be, but for not every case it is possible.
So, sir, if we extract 1, 1, then 1, 1 is a subset of the symmetric.
So in that way, you can say if we are just taking out the subset of a symmetric matrix. I need to check because I need to see for all the cases. I guess I don't think it that way, but I guess that should happen because if you are just because anti-symmetric basically anti-symmetric matrices. No, that should not happen, right? Anti-symmetric, that should not happen. See, let's for example, you can have a matrix. Sorry, not matrix Y because every time it's not matrix, it's a relation. Sorry, matrix because I'm reading matrix. If we have some function 1 1, 1 3, and 3 1, what is this?
This is
It's a
reflexive.
symmetric. It's
Sorry, symmetric.
This is symmetric reflexive. Symmetric. This is symmetric. Yes.
Symmetric.
This is anti-symmetric or not?
It's
No.
No, sir.
anti-symmetric, actually.
It can't be anti-symmetric.
Yeah, so
What?
x equal. Okay, x equal to 1.
If we have 3, 3, will that make it anti-symmetric?
If only you have 1 1 and 3, then you can say.
Then it will be anti-symmetric. And
So
identical.
anti-symmetric is defined on the set and symmetric is defined on the relation.
No. This who told you? So both are defined in the set S that has been already defined. Okay, the Cartesian product. Okay. So if we have some set S that is the Cartesian or maybe the subset of some Cartesian product, and then if we have a relation in that set S, for everything we are defining on that set S itself, nothing we are defining on any other. All the relation that we are defining, all are on set S. Okay, this clear? This should be clear to everyone.
Yes, sir.
Yeah. And it's like we are just wasting time. I know it's not important. So whatever I am discussing, let me discuss and then you can ask it out. Okay, because we are in first week itself and then we have to finish it till week 6.
So it is important, sir. No, not like it is not important. So what is asymmetric? Can you quickly?
Sir,
Sir,
if it is not
asymmetric
a
means it
question
is
in
not
that,
symmetric,
please move
right?
on, sir.
Sir, asymmetric means it is not symmetric, right?
Yeah, asymmetric.
Sir, if there is no question on this, we can move on, sir. Cover the
So I
topic,
think
sir.
it would be better, like if you before explaining any topic, you would mark it as important. So
Yeah, so I just noted down all the important topics only. Those I felt important for your final. After
Sir, can you just repeat
then it's fine,
anti-symmetric
sir.
alone?
anti-symmetric, I told you that we have a relation R that is anti-symmetric on S set S. Only and only there is one condition that for all xy and yx and yx is present in R, then x should be equal to y. If that is not agreed, that it's not anti-symmetric. Okay, I gave you example. Let's for example 1 1. As x is equal to y, then you can say it's anti-symmetric. Okay, and if you have 1 2 and 2 1, then it's not anti-symmetric. Okay.
Yes, sir.
Got it? And this is symmetric as well as anti-symmetric. So these are some conditions where some points. So that's why it's not the exact opposite. But you can say that asymmetric and you can say that it's the exact opposite. Is this clear to everyone till now? Shall we move further to the transitive
sir.
one?
Yes, sir.
Okay. I'll take the chat to allot out also, but in the end, because I can't take it now, we already have 1 hour. The transitive relation. So transitive relation also is pretty simple, it's not that difficult. Again, on the same set S, we have some relation R, and this is said to be a transitive relation if and only if for every pair of elements. And here also, everything is there on the R, not anything on the S. So here, for every pair of element in XY, if you have a pair XY, YZ present in R, then XZ should be present. Nothing else you have to check. Okay, for each and every pair, if XY is there in the set, if XY is there in the relation R, just go and see if any relation that starts with Y or not. If not, you can directly say it's a transitive relation. Okay, and that you have to check for each and every. So that's why for every pair of element you have to check. Okay, you just see for the first case. Let's for example, you have 5 elements in some relation R. So just check for the first element. If XY is present, anything else, any other set that is starting with Y. If not, go to the second word, second element. There also check for the y, like again, if you have like x1, y1, x2, y2, then check for the first case. If any element that starts with y1, not okay, well and good, go for the second case. So because of this, you have this relation is transitive. Now, not that overall the relation is transitive, but this only because of this element we can, if there was only this element x1 and y1, you can directly say it's a transitive. Okay, now check for any element that starts with y2. If it starts with y2, so what is the other pair y with y2? If y2 is there with z2, then search for x2 z2. And if x2 z2 is not present, then you can directly say that. So that is the only one condition that can help you to say that it's not a transitive relation. I hope. Okay, if this is not clear, let me go to some example and then. Oh, so I didn't write an example here, but okay, let me write some example. Yeah.
So,
Yeah,
this
go ahead.
is a very important relationship, and it is very confusing also because if you
Okay,
go,
I'll discuss with some example. Okay.
so I just want to say that if none of the condition falls, like the definition, then also that relationship becomes transitive.
See, if you have a set, so our set was S is what? A, B, C. Let's, for example, your set is that from where we are making a relation. If you have R equals to AB, only AB, is this a transitive relation? Is this a transitive?
No, sir.
How many of you are saying it's not a transitive?
Oh, no, it's just me, I guess.
Transitive.
Sir, it is transitive.
I'm saying because this definition is very confusing.
Okay, I'll just
Definition-
define it again. Maybe it will take some time, but okay, fine. So you
So-
have some S, and that is A, B, C, and D. So, and one relation is R is AB. How many of you, okay, if somebody, so whoever said it's not a transitive relation, why this is not a transitive relation? First tell me. I told you what is the condition. If XY and YZ is present, then XZ should be present. And if XY is present only and YZ is not present, so no need of seeing anything else. For this equation, for this relation, you have XY present. Is any element starts with B in this relation? No or yes? Any relation? Can you find any relation that starts with B? No.
No.
Okay. So do you have to check anything else?
No.
No. That means what? If XY itself is not present, you don't have to check for YZ and XZ. It's a transitive. It's a transitive relation. Other example, R1. If AB is present, BC is present. Is this a transitive relation?
Sir.
No,
Yes.
sir.
Yes,
No,
sir.
sir.
Yeah.
Yes, sir.
Yes, sir.
AC is not present.
No.
AC is not
Because
present.
see, for what did I say? This is
Okay.
AB. You have to search for, is there any element that starts with B? Yeah, there is one element, right? And what is the other element pair with B? C. So if this is present, then XZ should be present. If it's not present, you can directly say it's not a transitive relation. Okay?
AC should be present.
Okay.
AC should be present. But for this case, because there was no other element that starts with B, so you don't have to check for anything else. Okay? Is this clear to everyone, the transitive?
Yes, sir.
So, sir, I have one question. Suppose we have a relation where it is AB and CD,
A, B, and C, D. Okay, tell me.
whether it
You
will be
tell,
transitive or not.
you tell me what do you think?
I think it should be because
Yeah, so it's there because AB is there.
transitive.
Can you find anything that starts with B? No.
No.
Okay, so for this, it's passive. The test, whatever we are testing, it's passive for this case. For CD, is there any set, any relation, any element that starts with D? Because for us, it is XY. Anything starts with D? No. So for this also, it's passive. So it's a transitive relation.
okay.
Anything else? Anybody wants to say anything on this? If you have any confusion. Okay,
So
just tell me, yeah.
So can you take an example of a set of 1 and 2 and make a relation on that?
Okay, I'll just 1 S is equals to 1
1
and 2.
2
Okay,
and
you
relation
only
should
tell
be
me the relation. You only tell me this relation.
relation is pairing 1 and 2.
1, 2,
Second pair is 1 and 1.
1, 1.
Yeah. Now what? It is transitive or not?
Just see for this. First element 1, 2 is there. That means this is XY. Is there any element that starts with 2?
No.
Is there any element that starts with 2 in this?
No.
No. So for this set, for this element, our test path 1, 1. This is X and Y. Correct? For this, any element that starts with 1.
Yes, sir. 1,
Yes,
comma
Correct?
yes.
1, 2 is there. Okay. And if I told you if XY is there, that means this becomes YZ. For us, this becomes YZ. Correct? This is XY. This becomes YZ for us. And if I told you if XY, YZ is present, then it is must to have XZ. XZ is present, 1, 2 is present, and 2 is present. So this is a transitive, right? Did you get the idea? How do you check?
Yes, yes, sir. Yes.
Whoever has asked the question, is this clear to you?
Yes, sir. Got it. It means it is also dependent on the relation, not the set. Or it is based on both relation and set.
No, it's totally, see, all the element in the relation should be there from the Cartesian product of S. That is clear to you?
Yes, clear.
Okay. Because only the Cartesian product that I for so all the elements should be there from the Cartesian product.
So it means it should have any one element from the set, and if the condition as per definition is available in the relationship, it is transitive. If that definition, by definition, that set.
Our definition is only one thing. If XY and YZ is present, then only XZ should be present. If XY is present, YZ is not present, you need not to check anything else.
So it means now it is clear, sir. So
Clear,
by definition, it is we are defining that what is transitive, but actually the definition is saying that what is not transitive.
Okay, so
If you see the definition, it says that
R is said to be transitive if and only if for every pair of element X, Y, and YZ belongs to R. So it's not saying NC. So whatever this statement is saying, if this is satisfying this condition, this is transitive.
Yeah, right. But
so
this condition is not satisfying, then every set is also transitive.
See, if I have example 1, 2, whatever you told, okay. For this also this is satisfying because for this we don't have any other pair, no.
So, but
this saying for every pair of element X, Y, YZ is present in the set R. If X, Y, because it's a X, Y, and Y, Z is not present in our R. So we need not to check anything else, right? For at least for this element, we need not to check anything other element.
I got your point, but this definition only saying that if this such thing is available, then we can say that set or relationship is transitive. But this condition is not followed in case such pair is not available. Then also that relationship is transitive.
Correct.
I'm really sorry to disturb, sir, but it's 9:05 already.
So you can. I got my point.
Okay. So now we are going to the relation part. Relation we have done, and there should be some question from the relation that I can assure you. So just go and practice as much as you can from those topics which were like all the 3 things that I have discussed. Okay, at least this reflexive, symmetric, and transitive. Okay, if you're not able to get it, ask me maybe in the next session. You have like after this, you have only 2 sessions left. You can ask me, you can ask in the TA session wherever you want to, but there are some questions from this week, so you should be practicing as much as you can. Now we are going to the function, and function is simple. Like it's not basically it's a relation in which every element in set S is mapped with every like some element in set Y. Okay, if you have not got, there is some catch here. So one to many is not okay. Okay, if you are starting with some one element and then going to some two different elements, that is not okay. But many to one is okay. So if I am seeing, okay. So this is function. Okay. So what did I say? One to many is not okay. One to many, not okay. But many to one is okay. And then you can check it. You can do it with the vertical test also, but it's like the same. Okay. Is there any confusion checking out whether this is a function or not? So if it's starting from A, because it's the one to many, so this is not a function, but many to one is a function. Okay. Yeah, go ahead. Ask me. Okay, so function is clear to everyone.
Yes, sir.
Yes,
Okay.
sir.
Let's come to the type of function. Yeah, go ahead. What's your doubt?
Sir, I didn't have any doubt. I said yes to proceed.
Okay. Okay. So in the type of function, basically you have to read about the injective function, bijective and surjective function. And the injective is the most important, that I will tell you. You should be knowing which function is injective or not. And for the injective function, the definition is like everybody knows that each element in X set X is mapped to a distinct element in set Y. So here also there is a catch. One to many is not possible, because if one to many is there, that means what? If one to many is possible, it's not even a function. So for injective function, the first condition should be it should be a function, and then what is the other condition? Many to one is also not possible there. Okay. So for a function, many to one was possible. For injective function, many to one is not possible. Many to one means from many different values. Okay. So let's, for example, you have here subjective. Okay. So you can see that this is an injective function because many to one is not possible here. This is also not injective. Why? Why this is not an injective relation or injective function?
C and D are pointing to the same value.
Correct. Why? Because many to one is not possible. Okay, that's why it's not an injective function. And you can see there are other methods also to check the injective function that we will discuss in the later parts, maybe in the 50. But this is the, yeah. And one most important thing is, important feature of one function is what? If you have two different functions. So there are how many? It's like, see, how can you check one function? First thing is like pretty simple. If the function is an increasing function or decreasing, like some monotonic function, okay, strictly increasing or strictly decreasing function, then you can directly say it's a one function. Okay, you can check it with horizontal test also. If this if that is crossing, okay, I'm asking one statement. If f is an increasing function, then it's 1, 1. Second is, if g is decreasing function, then it's 1, 1. And the third is, if, okay, this is the sum of the property. I don't know whether you are knowing or not. If f and g is 1, 1, then f of g is 1, 1. And fourth is, if f of g is 1, 1, then f and g is 1, 1. How many of the statements are correct?
So the first two are true.
How many of you
First
think
two.
first is correct?
First two, sir.
First is
Yes,
correct.
first is correct.
Both are incorrect. Because I told you now, it should be strictly increasing. Okay, there is a difference between increasing and strictly increasing. Okay. Like increasing function.
Increasing means can x cube.
Yeah. Okay, you can have at some point. Okay, so if you are not aware of this, okay, leave it for you. If this is you are not aware of this, I think if not discussed, okay. So, but basically, strictly increasing a different thing. Strictly increasing, not even for a 2 point, the values are same. But for some time, let's for example, if you have some function like this is also increasing function, right? But from point x1 to x2, the values are constant, and you already know that it should satisfy the horizontal test. If this is a 1, 1 function, if you are just putting a horizontal line here, this is satisfying for more than 1 point, right? So then this should not be a what? 1, 1 function, correct? So it should be strictly increasing like this. Is this clear to everyone, or should I repeat it?
Yes, sir, clear. Thank you for bringing up.
Okay. The third thing is, if f and g is 1, 1, then f of g is a property you can just remember. I am not going to prove this, just you can remember. If you are getting some statement while a question in the exam, you can directly mark it. This will help you to solve some problem in the exam. Okay. So this property is very, very, very important for you. If you are not aware of that, if you have some function f and g, let's for example, I'm just giving you one function. Okay, where is that? That was there somewhere.
So what was the question to explain with log x cube?
What?
What was the question with log x cube? Can you tell?
Where? Okay, yeah. Check for so I told you.
So what was the question with log x cube?
Yeah, I'm discussing that. So I told you na, if f is a function, f and g is 1, 1 function. F and g is 1, 1. Then f of g will be 1, 1. Right? For this equation, what is f and what is z? If you have log x cube, what is f and what is z for this equation? Can you split it in f and g?
Log x and x cube.
So x cube is your gx, and log x is your fx. Is both are 1, 1 or not? X cube is 1, 1. You are already aware of that. Is log x 1, 1?
Yes, sir. Log x is 1, 1.
1, 1. Then log x cube will be 1, 1 or not?
Yes, sir.
Correct?
Yeah, got it, sir.
If you have some log mod x, is this 1, 1?
Sir, no.
No, sir.
Okay. I think so. It's like clear now. So
If the domain is from 0 to infinity, it would be 1, 1 maybe.
If the domain will change the domain, I'm just asking without asking anything domain, without saying anything about it. So this fourth statement is everything is clear for everyone. If you have been asked, you can mark it, right? How many of the statement? Okay, one is incorrect, second is also incorrect because it should be strictly increasing. Okay, and then third is correct. Fourth is the fourth correct. If f and g is 1, 1, f of g is 1, 1. If f of g is 1, 1, that means f of g is 1, 1 or not? Is this correct or not? This you can't say, like if you're not aware of that. Okay, so this statement also should be there in your mind. If f of g is being n, you can't say about f and g. Okay, so the inverse is not true. So the converse or whatever the inverse of this statement is not true. Okay, this fourth statement should be there in your mind. Okay.
So without knowing the domain in a general way, it can't be said, right, about f of g. In the fourth statement.
Fourth statement I told you, no, this is incorrect. That's why I told you, no, it's incorrect.
And if a certain domain is given, then we need to check that, right?
See, I just told you this statement is true, but this can't be. This can be or can't be. That depends on the function. So that is what I was saying. If f of g is 1, 1, that doesn't mean always f and g. That can be possible that f and g is like 1, 1. For us, for example that I gave you, there both the functions were 1, 1. Okay, but it's not possible always. This is what I'm asking. It's not all, but this is will hold always.
Excuse me, sir.
Yeah.
So, since we are saying that the fourth sentence is not possible always, shouldn't it be f and g is always 1, 1 for it to be wrong?
Yeah, it's always else. Sometimes can be, it's depending on the function, but always it will not be. But this will always hold the third state. Okay, let's move to the next part now. So injective we have discussed, and surjective is very different. Okay. The surjective is like the range is equals to codomain, or you can say that every element in the B, the other part, has at least one matching A. Maybe more than one, that is also possible. But at least one matching should be there from A. Okay, let's see the example. You have this surjective. Okay, what did I write? Let's check it. For each and every cases, you can see that. Okay, I am writing. I guess it's not whether this is injective or not. Can you tell me?
Sir, it is not injective.
Not injective. Why? Because many to one is not okay. Okay, and this is surjective because why this is surjective? Because for every pair
codomain is covered.
Correctly. For each pair, you have at least one matching from this set. Okay, there can be more than one, but at least should be one. Clear to everyone? This is injective, but not surjective because of phi. Okay, this is clear. And this is a bijective function. You can see that this is injective also because it's a 1, 1 function, and surjective because all the set, in let's for example the set x and set y. So all the element in set y is related to somehow it has a matching in set x. So this is clear, and the important point that I'm going to say about the weak one is should be knowing the relation concept very nicely and the injective function very nicely. Okay, the statement whatever I told you, f of g, g of f, that should be there in your mind. Okay, if you are there, if you are knowing this concept, I'm pretty sure you'll be able to solve the problems from the one end. Let's move to the second week. Second week is like pretty simple. I'm not going to discuss much about this. You should be knowing distance between 2 points, section formula, area of triangle, straight line, all these things you should be knowing how to write the equation, parallel line. Okay, can you tell me if two lines are parallel, what is the condition? What's the condition? Yeah, the slope should be equal, and the slope, the product of slope will be equal to how much?
Minus one.
So one important concept for this week is sum of square error. Okay, sum of square error, if you are knowing, it's well and good. I'll just discuss one example and that will help you to know this concept. Okay, sum of square error is pretty simple. The formula is this one, but okay, leave this formula. I'm just discussing if you have been given some model. This you can assume this as a sum model or some equation that follows y and x. You have been given a data x, because x is a data, right? Y is what? Y is a label, or y is the output of any equation. For any function fx, you are just applying x and you are getting y. So y is the output that you are getting. X is the data point that you are having. Okay, for each data, for any equation, basically in mathematical modeling, you have some equation. Okay, and you are assuming that should be following that. Okay, so maybe I have a model M1. And I hope that whatever the data and the y is been given to me, that should be following this model or the equation, this equation. Correct? Can you calculate the SSE for me? Okay, I'll calculate because that will take much time to calculate. So for me, what should be the y dash? From y dash is basically, so basically see SSE is what? Squared error. So what is the error that you are getting from? So what's the deviation that you are getting from the model that I gave you, or the equation that I gave you? From that equation, what is the deviation that you are getting from your data point given? Okay, for me, y dash should be what? So for this data point, the first data point, what should be the value of y dash? Can somebody tell me what should be the value here?
4.
Yeah, if you'll put 1 here, it will be 4. If you'll put 2 here, 6. If you'll put 4 here, what will the value? 10 you will get. How will you calculate the error? Because you are asking squared error, sum of squared error. So what you have to do? First, you have to calculate the error. So we have calculated the error. Now square the error. So 4 minus 5 square plus 6 minus 6 square plus 10 minus 9 square. Okay, and then do the summation. So sum the squared error. Calculate the error, square it, and sum it. And the values are whatever you get, 1 plus 0 plus 1. This is what the sum of squared error. Okay. Is this clear to everyone?
Excuse me, sir. Can you do one question from this topic? Like it appeared in the Q1.
So there is some question.
So it was in Q1 and that confusion. So like, can we discuss it in the next session then? Not now.
Okay, maybe we can discuss the remaining session, but I don't have that question from SSC. See, any question if they're asking, only this concept you have to. If you have been asked,
So from SSC, sir, from the sum squared.
yeah. Okay, I'll just ask the whoever
So
is
it's
to
question
just
number.
discuss discuss the question from SSC. This is what you are saying,
So
right?
can you please scroll up for a minute?
What? Scroll up.
Yes, sir, got it.
Let's move to the week 3. Week 3 is also very simple. So week 2, what did I say? The formula you should be knowing, all the formula, section formula, and the area of the triangle. If you have been given 3 collinear points, what do you mean by collinear point?
The
Area will be
line,
0.
line.
Yeah, so the area should be 0. So whenever you are given to ask calculate the area, just check it whether it's lying on the same straight line or not. So if you have 3 points, just calculate the slope. If the slope is same, let's for example this is M1 and this is M2, you can directly say that the area should be 0 because 2 parallel lines can't make a square and then the area should be 0. So every time whenever you have a point, 2, 3 points, so check the because the area calculating the area will like a lengthy work. Because mostly people give you collinear point to calculate it. Okay. Let's move
Can
to the
you
third
just
thing.
write the formula of tan alpha?
Tan alpha. Why do you need that tan alpha formula? What is that tan alpha?
And theta means the slope, and the slope if an angle is given, then how to find the slope that tan alpha gives.
If you have been given the angle, the tan value of that angle itself is the slope. If you have 30 degree, then tan 30 itself is your slope. This is M1. Okay.
If two lines are coinciding at a particular angle, then tan alpha will be M1 minus M2 upon M1 plus M2. Am I right?
That is like angle between 2 lines. So there is a
Yeah,
formula
yeah.
that you are already knowing. Right? Should be there somewhere, like you can just take it. I can write it, but it's like no point of writing it. Okay.
Okay.
There you can just write. It's like not that difficult. So if your doubt is just to calculate,
Just wanted to recall it. Otherwise, nothing.
so just you tell me what should be the value here.
M1 plus M. Yeah, it's correct.
So this should be the value. Okay, let's move to the week 3rd. Week 3rd is like also pretty simple. But the questions, you can expect some minimization, maximization type of questions from me. Okay. So this value, if you are able to remember, this is well and good, but I hope so you are already now knowing about the differentiation and all, like when the slope should be 0 and all. So now, even if you are not able to remember the formula, you'll be able to solve this. Okay. So if you have a quadratic equation ax square, if you have a is not equal to 0, then only it's a quadratic, otherwise it's like a linear the linear equation, straight line basically. If you are a is equal to 0, so it's a should not be equal to 0, then only it becomes a quadratic equation. And if a is greater than 0, then it should be which type of parabola, going upward or going downward?
Upward parabola.
Upward parallel. So see, one more thing you should be imagining is, if you have a quadratic equation and that is going upward, that means what you should be having, if you minimize, if you are calculating the slope, okay, if you are calculating, like basically you are differentiating that equation and equating to 0. So at that point, what should be the value? What should be, whether it should be minima or maxima for any parabola that is going upward?
Minima.
Minima will be there, right? So you can remember that calculate this. If you have ax square, you can just slow. If you differentiate it, 2x plus b. Okay, at minima, the slope will be what? The tangent at that tangent.
0.
Tangent will be 0, right? Tangent in 0 means it is making 0 degree with x-axis. Okay. So at any point, any equation, if you have minima or maxima, okay, like this also, if you have some minima or local maximum, any equation, it's not like out of your syllabus, but okay. For any value, like for example, this is a minima, right? This is minima, this is minima, local minima. Global is a different concept. So if you have a local minima, at that point also the slope will be 0. Okay, so here also the same concept is applied. If you are calculating the slope, so if you are calculating the slope, so at that and equating to 0, that means you'll be having at that point you'll be having the minima or maximum. So if the parabola is going upward, that means at that point you'll be having minima. And if it's getting to 0, you'll be getting some extra value that is minus 2a. And this should be the coordinate, x coordinate at that minima. Okay. And you can calculate the y coordinate also. How will you calculate the y coordinate? You can just put the value of, you can just put the value of x in that equation, right? And can get y. Is not it? Is this clear to everyone? How will you calculate the vertices?
Yes.
If you have been given
Yes,
any.
sir.
Yeah. So one more thing, in the exam, will not be given directly the equation. Will be given some context. Okay. So don't get scared with the some context. Like if the question is in some 5, 6, 7 line, just read it out. If you are able to read that, I am pretty sure you'll be able to solve the question. If you're just seeing the question that is a big question and then you're just skipping that, you'll lose the mark. That is pretty simple questions. For most of the quadratic question, there will be some context been given. Okay, for 5, 6 lines. Maybe you have to maximize some profit or minimize some cost. Okay, this type of problem will be given. But the equation that we'll be getting in the form of quadratic only. So don't get afraid after just reading for 5, 6 lines. Okay, will not be given the direct equation like I gave it directly, ax square plus bx plus. So it will be given some context of 5, 6 lines. You just have to read it, make the equation. If you are able to make the equation, you'll be able to maximize, minimize, whatever has been given, you'll be able to do that. Okay. And this is what you have to do. Just calculate the equation. If you have been asked to minimize the cost, okay, check whether this function parabola is going upward or downward. So that depends. So on depending upon the quality equation, you'll be getting minima and maximum. Okay. And similarly, for if you have a less than 0, then you'll be getting, but you'll be getting the maxima at that where the slope is equals to 0. Okay. The slope formula you're already aware of. X. Nobody is going to ask you that, but yeah, there can be question where you have to maximize some profit, minimize cost, and okay. How will you calculate the solution? You're already aware of that. It's a basic formula that should be known. Okay. And this is like not important. So, and you should be knowing how to calculate the square, the root of any equation or the zeros. The zeros are root are both same. Now we'll come to the 4th week. So the 4th week, one most important concept is how do you know the nature of the polynomial? If you have been given the polynomial, are you able to plot that? Are you able to know the features of that plot? If you are able to know that, this is well and good, you'll be able to solve the 4th week concept. So let's take a break of 2 minutes and then we'll start again. Okay, is that fine to everyone?
Yeah.
Okay, so we'll start with 4th
Excuse me,
week.
sir.
Yeah,
So till which week are we going to do in today's class?
week 6.
Okay, thank you.
The last so for week 3 quadratic equation problems, sir, the problems can be similar to the graded assignment type.
For whom?
For week 3, sir, quadratic equations, the context problems you were talking
Yeah,
about.
yeah, the similar type of problem. Yeah.
Thank you.
Just practice it. Okay, just I'll come back again at 9:33. Okay. So let's take it. Okay, let's start from the week 4. So from week 4, the polynomial itself, you just have to go through can you plot the polynomial? Okay, so you just go through that with one example. So you have this example, y equals to x minus 1 whole square into x minus 3 into x plus. Are you able to listen, like, hear me, right? I'm audible, correct?
Yes.
Okay. So you have this equation. How many solutions are there for this equation?
4.
4, sir. Okay, 4 solution. If you will just count the repeated solution also, then how many solutions are there? 5 plus 3. Okay, if you're just counting the repeated also, 5 plus 3.
8.
Okay, so the roots are -5, -7, 3, and 1. Multiplicity, you are aware of that? How can you write? What is the multiplicity of -5? How many repeated roots are there for -5? 2. 2. So similarly, you can write for -7 also, 3 also, 1 also. Correct? Now, can you know about the how generally you check the behavior of any equation? So see, one thing is, for any equation, even it's a polynomial, any log x, exponential, anything, if you are knowing the behavior, you can get an idea about the function. That is for sure. Okay, and how do you get the idea? Just check for x equals to, put the value x equals to infinity, put the value y equals x equals to infinity, check what is the value at y. Similarly, put the value at x equals to minus infinity and then check the value at y. Okay, this is how you check the behavior of any function. Okay, now let's come to this equation. What is the leading term of this equation? What is the leading term? Leading term is like, if you have
Positives.
Positive, right? How generally this is x square, from here it will be getting x, here it will be getting x square, x cube. It will be something x set with some positive coefficient of x square, x set. That means if you are putting x as infinity, what are the value you will be getting for y? If you have a function,
Positive values.
yeah, some form coefficient form x infinity. If you are putting some x to the power 8, if you are putting infinity here, because infinity to the power 8 will be getting some infinity value only. And if you are putting x equals to minus infinity, what is the value you'll be getting? If you are putting minus infinity, yeah, that means what? This function, what do you get what do you get from this two behavior? What can you say about this function? If you know that
tends to infinity, y tends to minus infinity, and as x tends to minus infinity, y tends to infinity.
That means
it will be upward from both the sides.
Look like an upward parabola, but in a haphazard shape.
Correct. So this function will start, because at minus infinity, we are already knowing that at minus infinity, the function will be positive infinity. And again, at some plus infinity also, the y will be infinity. So it will start something from here. Okay, you can start from here also. So it will go from here and will do something and then go here again. Or maybe you can, in the either way, start from here and go. That is not going to make any difference. So this is what I was trying to say. So from here, we got an idea how generally the plot will be. Any plot you can use. It was just a polynomial, but any plot you can get an idea. Now, just check how many. So what are the roots? -5, -7, 3, and 1. You can just write it here. -7, -5, 1, and 3. Okay. Now check. The function will start from here. So it will go down because you have a root. At this point, the function value is 0. Correct? If we are not having any function, if you are not having any roots, then how did the function would have behaved? Would have went something like this, right? Correct? Because if you don't have any
touch x-axis.
Correct. So if you don't have any root, it will not cross x-axis. Correct?
So
yeah. Okay. So now you saw that you have a root at 1, 3, 7, -7, and -5. Now we have started from here. Now because at this 3, the function value is 0, so you should be connecting this from minus infinity at -3, the function value is 0. Now you need to check that what is the multiplicity. So there is something that you have to just remember. At 3, Add 3. What is the multiplicity? Odd or
Three.
even? Just check it whether it's a
Odd,
odd or
odd,
even.
odd. It's odd.
If it's a odd number, what should we do? Whether it should reflect back or it should cross x-axis.
It will cross. It will cross.
Correct? So whenever you have an odd multiplicity, it should cross x-axis. Okay? So we were having what? We were having odd number, so it crossed. Went back to 1 because we have to go back to 1 because at that point again the function value is 0. Right?
So
Is this clear? Now we'll start with, now check the multiplicity at 1. What is the multiplicity at 1?
even.
Even. So if this is even, then it should
Bounce
go,
off. It will not cross.
back and go to -5 because at -5 again the function value is 0. Now check the multiplicity at -5. This is even again, so it should bounce back again, go to -7 because again the function value is 0 at -7. And now at -7, this is odd. So
Sir, how do we know that when x tends to -infinity, y tends to infinity?
okay, because we know that the function starts with some positive coefficient x to the power 8, and then there is something. From this equation, you can get an idea, right? This is x square, this is x. So if you multiply all the x coefficient, you'll be getting something x to the power 8. And as the coefficient is 1 for each of the cases, you'll be getting the coefficient as also 1. Correct?
Yes, sir.
Yes. Yeah. If you put x equals to infinity, you'll be getting y as also infinity, right? If you have x to the power 8 plus some equation, this is the leading term, right? This value should be maximum. Okay.
Okay, sir, got it.
So we have to, sir, we have to calculate the whole power. I mean,
No,
add
you just have
all
to
the
calculate
powers
the
of
leading.
x.
Yeah, just add it and check whether the coefficient. Let's for example, if this was -1, then you'd have got what? If this was -1, then also you'd have got positive number because -1 ka square will be like 1 again. But if this was -1 here, then you would have got some negative coefficient.
Negative infinity.
Correct. This is what you have to check, and this you can check for
Because we take common as -1.
Yeah. If this is -1 here, then you would have taken -1 as. Okay, and then you can just take the leading term. Based on the leading term, you can get an idea from how to start and how to end. Okay, if you just got the idea about how to start and how to end, just check for what are the roots. Okay, and the multiplicity. If the root is there, because at root the function value will be 0, so you have to connect it. Okay, and then check for the root the multiplicity. If the multiplicity is odd, that will cross the x-axis. If it's not odd, like if it's even, then it will just bounce back. Okay, and this is how. So you can be asked. See, how will you ask the exam? You can be given the equation, and then roots. Okay, so the multiple root. Okay, these are pretty simple. 4 statement can be given and can be asked how many turning points are there. Can you tell me how many turning points are there for this equation? If it starts from here, while going here from here to here, how many turn you are taking?
2 turning points.
3.
Okay, I'm starting
Four,
from
sir.
here.
4.
I'm starting from here.
Sir.
I'm starting from here. So there's 1 turn, right, that I'm taking. Again going in this way. Again I'm shifting. So second turn is this. Again I'm going in this direction, but I'm turning back. Again I'm going this side and turning back. So this is the 4th turn. This is the 5th turn. So you have 5 turns. If you have been asked in the exam, you'll be able to solve, right? Okay.
Yes.
Yeah. So polynomial, if you are just knowing this concept, okay, and maybe you can practice some problem from the graded assignment. Okay, just practice some questions from the previous term paper. I'm repeating this again and again. If you are able to solve this previous term, whatever the time you have, 5-6 days, practice this. Go through the slide that I have shared you. For each concept that I have written, you should be solving the problem from PYQ. Even PYQ, though you are solving all, but each topic they will be solving from the graded assignment. If you are able to do this too, I don't think so you'll be able to miss any question. Okay, let's come to the 1-1 function again. Okay, and for 1-1, one thing that I told you, f of g was very important concept. Okay, for any function you have been given, you can use that concept. Okay, to know about whether this function is invertible, what or not. What is that invertible function?
It should be both 1, 1 and 2.
On 2. Why is that required? On 2, why is that required?
Only 1 to 1.
Now, 1 to 1, if this is a 1 to 1, you can directly say, right? This is a 1 to 1 function. You can directly say it's a invertible, right?
It should be bijective, sir.
So one input and one output.
Yeah, see, for inverse function, what do you need? Tell me. If A is related to B, that means from B also you are getting something A. So, see, so for each of the point, you have some unique value in the other set. Correct? 1, 1 means what? Each of the element is related to some other element. Okay, and if that is occurring only that thing, then you can directly say it's a 1, 1, like it's an invertible function. That's why you do horizontal test now. If you have a horizontal test, if you are doing, and if that is crossing only one point at one point, then you can directly say it's a 1, 1 function. Okay. Is it clear to everyone?
So
How do you check? Okay, tell me how do you check? What? Bijective is like both should be satisfying both the condition. What did I discuss? Bijective, that 1, 1 and this surjective, the surjective, okay? That the codomain should be equal to the, like the range should be equal to the codon. That means each of the element from here, like if you are having a relation from set A to set B. So each of the relation in this set B should be having one or multiple connection from set A. Okay. Okay. Is this clear? So there should be some connection from this set. Is this clear? This is
yes.
Okay, and if both the things are occurring, that means this is 1, 1 also, surjective also, then you can say that this is a bijective. So I told you 1, 1 you should be knowing, like very important. That means for 1, 1, what are the conditions? Okay, can you tell me 2 to the power x? Is it an invertible function? Can you invert it? Or is it a 1, 1 function?
No, if there is a 1, 1 function, it is inversible.
No,
Yes.
sir. No.
Yes, sir, it is 1, 1.
I told you some exam. I told you how do you get the behavior. See, that is not only for polynomial. You can just put it x to the power infinity. If you are putting x to the power infinity, what are you getting? Y equals to
Infinity.
If you are putting x equals to minus infinity, what you are getting?
Minus infinity.
Hey, how can you get minus infinity? 2 to the power minus infinity. What is that value?
Oh, sorry.
Not defined. Not defined.
Yes, that's infinity.
Not defined or 0.
It's
You'll be
tending to
approaching
0.
Will approach to 0, right?
Yes.
Correct. Correct. So this equation should be how will it, so for x equals to infinity, it is infinity. You don't have any root because you already know that 2 to the power x, any exponential value is not cut this x-axis. Okay. So for x equals to minus infinity, it should be 0. So this will be something like this. Correct. And you can see that this is satisfying your horizontal test. If this is satisfying, that means the 1, 1 function, you can invert it. And this is how you get the log function, right? From here. So this was pretty simple. If you have log, some exponential, you already know that you can get the log from that 1, 1 function. Okay. Is this clear to? And then you can see. So I told you 2, 3 methods, right? If you have some function, if you are able to plot this is an increasing function also, right? Is this an increasing or not? Strictly increasing. You can see that.
Increasing.
Correct? Is
Yes.
it in strictly increasing, right?
Yes, sir.
For any value, you can see if x1 is, if x2 is greater than x1, that means the function value at that x2 also will be greater than x1. Is it clear to everyone?
Yes.
Shall we move forward?
Yes.
Yes, sir.
Again, one more important thing is the composition of function.
Excuse
Second
me,
of
sir.
all- Yeah, go ahead.
Sir, I was looking to the practice assignments of the week, like this, 1-to-1 and subjective and surjective and injective, and I came across a question. Can you do this? Y is equals to x squared plus 1 it is given that the answer says that it's not injective nor surjective.
Okay. So I'll just finish this week 6 and then wait and then we'll just discuss that. Okay.
All right, sir.
Okay. So we'll just finish it in maybe 15-20 minutes and then we can.
So till what week will you be discussing?
16. Okay. So I told you
Sir,
about
after
this.
the 3 revision sessions, sir, is it possible to take till week 5 and then clear the doubts?
No, I have been told to discuss it
Okay, sir.
because the weightage of those weeks are high, so that's why they have been bigger sessions for this week. Okay. The weightage is not that much from week 1 to 6. That's why we are just covering it up. What are the important things that I'm just discussing? Otherwise, like the concepts, like more concepts I will discuss. But we are just discussing all those points for this. Okay, so strictly increasing, decreasing, I've already discussed. You check one, you can check it with anything like strictly increasing, strictly decreasing, or you can just plot that function, check for the horizontal test. Okay. Anything else you can do, and this also I told you. For any function a to power x, you can just get the behavior by putting x equals to infinity, y equals to infinity. For x equals to infinity, it will tend to infinity. For x equals to minus infinity, it will tend to 0. Okay, and then you can plot it. Is this a 1-1 function?
Yes, sir.
It's a 1-1 function.
This is in particular. This is how you check for simple equation. This is this an increasing function?
Strictly increasing.
Yeah. And if we say
Sir, can you
also,
explain what is an asymptote, sir, for these graphs?
Asymptote is like this, which is tending to x-axis, right? For some parabola or something. If you have something, this type of plot, that means what? This equation is having asymptote x equals to 0 and y equals to 0. Okay. Where is this taught? Asymptote and
So it was taught in the lectures.
okay. Okay. Let's come to this composition function. I guess the left part is the composition function, and that also you should be knowing how to solve this equation. Okay. How will you calculate the domain of f of g function? This I have explained you in the last session also nicely, but again I'll just discuss it. For any function that is f of g, so you have some f function, g function, okay, and you have to calculate the domain of f of g. How will you calculate this? What are the two conditions that we checking for? The first condition is what? If some value that is not in the domain of gx, that should not be in the domain of f of g also. The first one is simple, right? The first one is simple or not? It's clear, right? The first one, you are able to know that.
Yes.
Is there any doubt in the first equation?
Can you give an example, sir, to simplify it?
Okay, so just give you one example. Okay, yeah. If we have a function fx, yeah, so here is example. So fx is given, gx is given. So for gx, what is the domain that should not be included? What is the value that
0?
0 and I think only 0.
So r minus 0 is basically the domain. Okay, any value you can put it, only the 0 should not be there. So the first statement told that if you are calculating f of g, if you are not able to put 0 inside this function, how can you put that 0 inside this function? So this is what it's saying, the first statement. If x, for some x that doesn't belong to the domain of gx, then that value should be excluded from the domain of f of g also. Okay, first statement is clear. Now the second statement is.
So what is x bar g of x stand for?
What x bar? This value.
Yes, sir.
Probably
This I haven't discussed.
is
I'm
less than
discussing it now.
minus 1. So
Sir, what is x bar g of x stand for?
Where is that x bar? Where did I write x bar?
Sir, no, sir. Can you just explain the statement?
First statement. Okay, first statement is if x doesn't, this is doesn't belongs to. Does not.
No,
belong
sir, no,
to.
sir. That I understood.
She
Can
is
you explain
asking
the
about
entire
x
statement?
such that gx is, does not belong to.
Ah,
Okay,
yes, sir.
this
That one
statement I
only.
didn't discuss it. Okay, The first statement is simple. The second is you have to exclude some more values. And what are those values? That x such that gx is, so you have some value in it. So I'm just giving you some example. So you have some value. So let's for example this function is. What is the value that is not included in fx, the domain of fx?
One.
Once.
One.
R
So
minus
you have to exclude all those values of x where this function gx is equals to 1. Did you get the point? You have to exclude
you have to remove
all x where gx is equals to 1. That means what are the value where gx is equals to 1?
3.
3, sir.
So you have to exclude 3 also. So what should be the domain of this f of g? R minus 0 minus 3. Okay, 0 we have removed from the first condition. From the second condition, we have to remove all such x where gx is equals to those values where domain doesn't exist for fx. Okay, I hope this is clear. Is this clear?
So we'll not
Should I
remove
repeat it?
one.
Why 3?
Yes, sir.
It's not clear, sir.
Yes, sir.
Okay. So the first statement is you have to exclude all those values of x which are not in the domain of g. The second statement is you have to remove the values of x. So the values of x at that point where your function gx is equals to those values which were not in the domain of fx. For example, here for fx, we know that x equals to 1 is not in the domain of fx. Okay, so we have to remove all those values of x where gx is equals to those values where fx was not defined. So fx is not defined at x1, so gx equals to 1. Okay, and now what are the values? Which are the values where gx is equals to 1? So 3 upon x equals to 1, that means x equals to 3. So we have to exclude 3 also. Is this clear now?
Yes, sir. Yes, sir.
Should I write that?
Yes, sir. Clear, sir.
Yes, sir. Yes, sir.
Yes, sir. Thank you very much for this. Yeah.
Okay. Shall we move to the last week? And the
Yes, sir.
last week is pretty simple. It's just the log function. And one more thing. All the properties should be there in your mind. I'll give you one question. And if you know those properties, you'll be able to solve. These are the simple properties that you should be knowing, okay, from the log function. And again, from the log function, you'll be getting the similar problem that you were getting in the quiz 1 or quiz 2. I don't know, quiz 2 you have got. Number of solution. What is the number of solution for this equation? Can this be an equation solution? Let's, for example, this is your problem. Okay, how many solutions are there? How many solutions exist? How many solutions are there for this equation?
2 solutions, sir.
I hope now. Okay, just tell me. I guess this is incorrect.
Quadratic equation. 2 solutions.
No, sir. Only one.
2 solutions.
one
we'll
will be-
taking, 3 to the power x as variable, one of the variable, and then we'll be converting it into quadratic, and then we'll be
Only
solving.
once.
This is what you do the mistake in the exam also. This is quadratic. You can convert that into quadratic, but you will not be getting 2 solutions. One solution will not be in the domain of that whatever you are taking, like whatever the, let's for example, you're starting with what? They're putting some 3 to the power x equals to t, right? You're getting t square minus 2 into 3 into t minus 27. The solution, what are the solution that you are getting?
9
One of the
minus 3,
solution
sir.
is minus 3
9
and
minus 3.
9 plus 3 and minus 9. What did
Minus
you say? Minus 3. Can you get 3 to the power x equals to minus 3 in any case?
No.
No, sir.
No, right? So how can this be a solution? What is the value of x where this equals to -3? Is there any way that you can get this? No, right? So this is not the solution. So now 3 to the power x equals to 9. X equals to 2 is the only solution. So how many solutions there? 1. This is what you will do in the mistake in the paper that I saw is like not that difficult. It's like pretty simple, simpler than the quiz 1 and quiz 2 that we've solved. But if you do this kind of mistake, I guess. Okay, now we have one more question. Okay, graph theory and all we'll discuss in the later part. Okay, so now this is your question. I think this fits your data point. Okay, so this is the equation. I think this has which fits your data point. So this is the equation that has been given. This is a bigger equation, log 10111 log 101. So this is on the power of this 1001 is the base, again 101, and this is again the power on 101 plus k into this one. Now you have to calculate something. Okay, can you simplify this equation first? Are you able to simplify using the log or the like properties? Are you able to do that? If you have pen and paper, please do that. Just simplify the equation. How will you simplify this?
Sir, log a to the power log a is o to the power m is equals to n.
How will you
First,
simplify?
we'll be taking the common term as some variable and then we'll be simplifying.
How will you do that?
We'll be taking the
See.
common term as one variable, sir.
Which term?
X to the power 5
X to the power 5. Okay, you
minus 5x cubed plus 4x. Yes, this will be
Yes.
taken as some a or some other variable.
Okay, you can take it as a. I don't know if you are taking some. Let's for example. So I have solved this equation. This was one of the difficult problems. But if you are just knowing the concept, you'll be able to solve that. And here also the SSC ka concept also. So one question of the SSC also you will solve.
So can you explain this question again?
See, we were having. This was the y. So see, this is basically a question of SSC, like sum of squared errors. Okay, and what was the question? You have this equation. So the model follows or the equation, the whatever the data point that you have got. So this is a given data. Okay, and this data follow this equation. Okay, and then you have to minimize the squared error. At what point, at what value of k, the SSC, the error will be minimum. This is what you have to calculate. Did you get the question? Did you understood? So you can just split this question. The first question is, this is the equation that you have got. This is the equation. Y cap is the equation that you have got. And you have been told that for this data, that should follow. Okay. So SSC, what we were doing? We were calculating the error, right? We were calculating the error from the given equation, right? So if you have been given some data points, if you have given some data points, and then been asked that the data point is following this equation. Okay, then what generally you do? You put the value of x and calculate y cap, the error. Okay, and then you calculate y cap, and then you calculate the error as y cap minus y. So what's the deviation from my original label? And then you just square it. But here you have been asked, what is the value of k such that whatever the SSE that you have calculated, the error that you have calculated is minimum. Okay, so how will you do that? Just tell me the procedure. How will you do that? If somebody, so this question have a concept of quadratic equation also, the log also, and then SSE also. How will you do that? This question, tell me. If somebody is getting any idea, just let me know.
So maybe first we will simplify this, and then whatever the quadratic equation we get, and then we will calculate the vertex, and based on that we will identify the minimum value.
Repeat it. I didn't show that. Can you repeat it? Repeat
Sorry?
that. Yeah, repeat that.
I'm saying I think after solving that quadratic equation, we will have to look for the vertex for which we will be getting the minimum value for that k.
The method, whatever you have told, is correct. Okay. But how will you simplify this equation? That equation that you are seeing,
I
you have
don't
to
know,
use
sir.
that. Yeah. So whatever the method that you have told is totally correct. You will be getting some simpler equation, then put the value, calculate the error. You'll be getting some quadratic equation, calculate the vertices, or maybe just do the differentiation, equate it to 0, get the value of x. Okay, at that point only you will get the idea about the k. Anybody who has done the simplification for this equation, or should I solve that?
We apply the base change property in the numerator of log 1101.
Start with this. We have taken for simplification, you just took. So whatever one student was saying, just take this as a or lambda. So I took it as a lambda. Okay, so this is also lambda. So this become equation log of 100, 101, 11, and this I took it as a lambda, but this whole I took it as a. Okay, so I just put it as a plus this equation. That is fine. Next case is what? This will come here. A log 10111, and this is fine. Then again, what will you do? What next? A, can you write it? Now you can write the A, right? So log 1001101, and this I just took it as lambda. So I can write it lambda here. Now again I can I write it here? The lambda times log 1001101, log 10111, and this value. Now what will I do? Lambda I already knew. Can I write it like this? I can use it, right? Log 101 upon log 1001. And base I can take anything, right? If you have something, log AB, I can take anything. Log B91, log 91A. I can take it like this. I just took it like this. Why did I took? So that I'll be able to cancel this, because that 1001 was coming in the multiple of 91. Okay, so I'll take it that value, and then this both got cancelled. Now we are remaining with this 2. So this also will get cancelled because 1001 is a multiple of 91 and 11. So this both will get cancelled. We'll be remaining with log 91, 91. So now this is 1. Now we are left with lambda 1. So lambda plus k to the power 5 lambda. So this is the equation that we have got after simplifying. Now what did you do? Now you have the equation. Just put the value of x. Now get the y cap. Okay, we got the y cap. So we got the y cap for each of the value. We got the y cap as k. Now what will you do? Now calculate the error. Calculate the error. We have calculated the error. Now, so whatever C has told, we have got the quadratic equation. Now you can calculate the vertices. As this is a going upward, you can calculate the vertices. I calculated, just did the square root. Then I calculated by just putting the slope as equals to 0. And you got the value of k equals to -6. Is this clear to everyone? Was that a difficult, or how did you?
Please scroll up.
Sir, 91 multiple 1001. That is a difficult part, sir. We can't get it actually. That tables and all we didn't study actually.
Why did, see, if you are solving this question, see, this part was clear. Whenever you are writing, so see, you can write it, it's something like this also, log A, right? You can write it, there's no problem. Log A. But if you write it log A, okay, you'll cut this both values, but now you'll get stuck with this 2. Because this A you are not aware, and you are already knowing that You can take any value of A. So why not you take something that is multiple of, so this question was framed in such a way that this 1001 was a multiple of 91 and 11 of this. That's why it was.
We need to divide 1001 by 11, then find the 91. And then we need to get
it should be, so when you were taking AA, so this you were aware that this should get cancelled, but now this should get cancelled, because then only you can proceed, right? Because
yes,
if you are
sir,
not
got
correct, so then you should be checking whether, okay, what should be the base I should be taking, because any base, this both will get cancelled, any base we are taking. Only the thing is about this two. Okay. So this is what we should be thinking. This is what you have to think. This is how you have to think. But this is the most difficult problem. I don't think so this type of problem will be there. This I just gave you just for the, you should not get shocked with exam if you are getting some. So 1-2 question can be like this, but most maximum 1 or not all. Okay.
Yes, sir.
Yeah, one
Sir,
more question is there. Just try to solve this question. If you have this function, calculate the distance length of AB. If you have something like this, if you have a plot log 2x and log 2x minus 8, how will you calculate the length of AB?
B minus A.
Sorry to ask, but how long is the session for?
Yeah, this is like this is the last question, and after that the streaming will stop. The doubt and all you can ask. I'm totally exhausted because I was having 2 sessions of like ML session, and then in the morning, and then I was having this proctoring thing for 4-5 hours, and then this is the last session that I'm having. So I'm totally exhausted. So this is the last question that I'm discussing today. After this, you have a doubt, you can just mail me. I guess people who mail me, I generally reply that whenever I have a time. Mostly I just reply. Some people were asking the PYQ. I just gave it the PYQ, but I told the team also to upload this. I have this uploaded. Okay, so this problem you can solve it from your side, right? This is not a difficult problem. Any function if you have been given, you can just see what is the value of A. How will you check that? Just check the value of X where Y is 0. For any function, this is crossing X. That means you are checking for all the values of X where Y is equals to 0. What is the value of X where the Y is equals to 0? For this log X, what should be the value of X?
1, sir. 1.
1. Correct. And here it should be
9.
9.
9. Correct. You can calculate the length. Okay, so this is the slide. If you have any more doubt, you can I just write it. You already know about my mail ID, right? I'll get it. study.iitm.ac.in. Okay, you can mail me any doubt you have. But you have because I have some more like the thing like elective that where I have to take the revision session also. So I don't know whether I'll be taking the next session. But if you have any doubt, you can just ask me.
Sir, integration part. Can you just say which area we need to concentrate on integration?
Okay, integration. I'm really sorry. Like which portion?
Sir, there are like part integration by substitution, integration by parts. If you can give us some clue, like which we need to focus on.
Okay. And seriously, I'm not aware. Like the concepts I'm aware, but I don't know which part should be concentrating.
Sir, Riemann sum will be coming, or the directly limit application will be coming like that.
Excuse me, sir.
That we can't say. Like, okay, I'll try to in the last revision session, I'll try to come for some time and then maybe discuss the integration part. Yeah. Arnav. Okay, is that fine?
Sir, waiting. For editing.
Or you can what weightage? Weightage I told you in the starting, the week 1 to 6 is not that weightage, maybe 25 to 30%, and the remaining portions from week 7 to 11 is like 70-75% of weightage. So most of the concept are from the end week from week 7 to 11. And if you are good at graph theory, you'll be able to score some 40% from those parts itself. Okay, so focus on the graph theory, spanning tree, how to calculate the minimum cost of the spanning tree, those things. Okay.
Excuse me, sir.
Thank you, sir. Thank you, sir.
The spanning tree and then what you said?
Spanning tree, minimum cost, how to calculate minimum cost, and then there are any algorithm like some basic concept about the algorithm that has been discussed, right? T3 algorithm that has been
Excuse me,
discussed.
sir. I did not understand the
Sir,
last question.
is it, sir, is it the
Of the-
mail ID that you have uploaded in the chat?
What?
Sir,
Sir, I did
is
not
it the
understand
mail
the
ID
last
that you have
question that you
provided in
did.
the chat?
One by one in the chat. What?
Yeah, so is it the mail ID? Is it your mail
Yeah.
ID?
Yeah.
Okay, sir. Thank you, sir.
Okay.
Sir,
so
do you have the revision PDF for the 7 to 11 with you? Can you
7
share
to
that,
11?
sir?
That I don't have, but the person who will be taking will be sharing some files. Okay.
So can you share this PDF in the
I
chat?
already said this.
Sir,
Sir,
I
I
did not
didn't
understand
get
the last question that you did.
Okay. So last question I'll just discuss it. And that with the last problem was what was that last problem? That which
Sir, it
one?
was about loan.
Yeah, so for some graph theory, the concepts are there that you can realize it. Okay. Some person just took it the revision session for some people where this graph theory I discussed, some of the concepts are there. This question?
No, sir, the last one, it's on the last side.
Okay. You have to calculate the length AB. If you have any functions, like let's for example, this is not log function. Okay, that I can't delete it. Okay. So this is some function fx, and this is some function gx. So how will you calculate the length? You have to calculate the x such that where fx is equals to 0. Let's for example, this is x1. You have to calculate gx such that at that point x is gx is 0. So you have to calculate x such that gx is equals to 0. Let's for example, this is x2. So at x1, fx is 0. At x2, the gx is 0. So the difference is what? X2 minus x. This is the length, right?
Yes, sir.
Okay,
Sir,
so
can you resend it? I joined late actually. That's why.
Okay, resend it. Okay, can some of you send that file again in the chat box? Okay, or should I let me share it again? So yeah, I've shared it again. Hopefully you got it right. So you can just download it from there. I'll just so for any more further doubt that you have, you can just ask me. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you, sir.
Okay. All the best, everyone. And
Thank you, sir.
yeah.
Thank you, sir.
Thank you so much.
Thank you so much, sir.
Okay.